yesterday's President's talk, Man with AI. So we are going to discuss on the case study where it has helped us to bring down the specific chemical reduction in SP. What we see are we have integrated QEGHS policy where Q stands for quality, environment, energy, green resources, health and safety, and we are certified for the same. These are all the integrated pieces of a larger puzzle. So we work together to make a holistic approach for sustainability. We all discussed for the past few days about recent trends, what are the present challenges, say the resource utilization, the raw material scarcity, the adaptability and scalability of each and every aspect of our industries, quality compliance, because every time the demand changes. So we have to focus on what the customers need and the supply chain efficiency to bring down. I can make this this is on a larger picture, but we can nullify into 2 points. One is on the energy and the environment. So these are the major challenges what the industry faces. So to overcome, we have to focus on the efficiency as well as focus on sustainability and cost reduction. So it will take care of the bottom line. In SPB, we adopt the RDS technology for cooking, and we have 2-stage ODL, and the bleaching sequences D0 where D stands for CO2, so D0, EOP and D1 stage. And the ISO brightness we work on is 86%. So the purpose of bleaching, as everyone knows, is to remove the lignin and impurities to have the final brightness. Some of the limitations what we have are reliance on the fixed parameters and really on the operator experience, raw material variability. It was earlier a monthly basis, now every shift or every hour there is a variability, and difficult to and process variations, overconsumption of bleaching chemicals, in turn it affects the effluent loads. So coming to the topic, this is the power of reliance. Yesterday everyone has dwelled on this, but I would say AI offers precise control, optimized chemical usage, enhance consistency, improve sustainability, as it learns from the vast amount of data to identify the complex relations. And it also adjusts to the dynamic variabilities of our process parameters. You could recollect yesterday's keynote speaker's topic, where to start, how to use this AI in our system. Think big, start small. So we have adopted in our bleaching sequence. So where we can definitely see the savings. So the objective of our bleaching system is to have 2 manifolds. One is to reduce the final brightness and minimize the chemical consumptions. Before that, I would like to also say that when we made the ABC costing, the activity-based costing, one of the area is the bleaching chemical, or you put the other way, you make the use of the Pareto chart, where you work on the 80-20 principles. So bleaching is one of the key area where we can definitely save. And it is controlled by optimizing the pH at each level, say in D0, EOP and D1 levels. The software we use is MAX, where it stands for multiple variable advanced control, and it is a model-based predictive control. So everyone knows the key components are the machine learning algorithms, advanced data analytics and predictive modeling. So the max beach control takes care of these. Without measurement, we cannot control anything. So to start with, we have installed the bleach load transmitters, pH sensors, as well as the brightness transmitters to take care of all the variables. And the control strategy, what we adopted is feed forward and feed backward. Where feed forward, anticipate the changes based on the measurements, and feed backward takes care of the process to ensure smooth operation and efficient operation. So measurement was taken care. Coming to analytics, the results from the loop tuning, analytics and loop tunes. You could see the difference with old tunings and the updated tunings. So the effective loop tuning helped us to better response and stable system, and the recommenders based on the parameters. So you have taken care of the loop tuning based on the max control. We all know where to have the D0 or DOT and D1, what to control. So dynamics for the D0 was based on the kappa number, and for DOP where the caustic and the peroxide are important, pH was taken as the input, and for the D1, both forward as well as the backward controls were taken, so that the final brightness is taken care, and the acid control, as we didn't have online measurement, so lab readings were also integrated for the This is one of the curves taken from the literatures. The purpose of acid DOP or to take care of the caustic or DOP acid or the caustic, it is to make for the reaction to occur, not neutralize each other. So that is the purpose we are, what level it will help us for the stable operation so that the reaction occurs. So coming to the tailored control, could see for the control variables and the projection models, feed backward was considered, and for the projected models, feed forward was considered, and we have the manipulated variables and the control variables. Each stage are mentioned here for the D0, feedback control based on the kappa, EOP for the both the inlet pH as well as outlet pH, and the D1 both for the D1 CO2 as well as the outlet pH of the pH, inlet pH and the sulfuric acid. So both feed forward as well as feed backwards were taken in line. We were all seeing all the positive points, but this is the advantage of AI. If my sensors get coated, what to do? So here comes the software sensor, and the moment our sensors get coated, the software sensor roles becomes much more critical. This is where the AI helps, wherein it takes the operator data and the AI integrated data, where it merges and still helps us to get the results without much variation. And we clean the sensor. It is what we see is the sensor is not hard coat, it's all soft coats. It's because from the raw material we get. It is momentary. We were trying to analyze what is the sample, but moment we touch, it washes easily. So we are not able to control, but we have given the sample to lab, we are waiting for the result. So how the operator sees this in the DCS? He is not able to see the complete max reach control, where what is the D0 level, CO2 is going, D1 CO2 is going, and what is the predictive, what is the next step. So by this, operators are made free, they can work on the other critical parameters. This is how this AI helps us in our reach plan. And they can also see the future prediction of the manipulated variables and the control variables. What we have seen are the trends, but this is the DCS page where AI is the watchdog. You could see W dog there, WG. So it takes care. The point here, when we have to start the max control is first we have to make the system stable. Then we are giving to the automated mode, like it is like cruise control, where you set the car at 60 or 80 km speed. Then you press the cruise control. It takes care so that you can rest for say 30 seconds or 40 seconds, and the road is clear and you know when to take care in line. So that's how it works. We are getting the process variable, the set point, and the steady state. Yes, is the system is steady? Yes, system is steady. And what is the minimum set point for each variable, and what is the maximum set point? So all are taken care. And we are given still the option because anything can change, or still we have not made 100%. The operators are given an option. They can come out for the cleaning of the sensor. See, we need not come for we can opt for the DCS mode still, take the tunings, again come back. So as we are all having the hands-on experience of the pulp industry, so it has become quite easier. So the team who comes in the next upcoming years, request is they should have some hands-on experience before you go for the AI. Now the day has come that someone says, what is 1 square? He is opening the calculator and saying 1 into 1 equal to 1. So that should not happen because of this AI. So people should work on, use some brain, some common sense. That is my sincere request. This is the overall performance, wherein earlier only DCS we cannot load this much data, but with the cloud availability you can store the data for months together, years together based on the capacity. These are the table form. You can get in the web chart or the other bar charts, other things. You could see there is a differences. You can see your progress, how we progress in this month, how we progress this month. Is it based on our raw material this month, or we can compare each month data to analyze ourselves. You could see the results are, there is a significant reduction for the before and after 10 months. Though the chemical reduction looks small, but in turn it helps on the environmental aspect to bring down on a smaller footprint. Initially we started for the CO2 and hydroxide, but we could also see there is a significant reduction in peroxide. So we are seeing how it started and what are the variables we have taken care. And finally the results, what you see are the reduction in CO2 by 1 kg. Someone may ask, what is 1 kg already? Sir, we have already reached a threshold by operator's experience or based on our different error and trials. Now to make from 95 to 100, we need that artificial intelligence to further bring down the variables. So this is where we have started working on. So it is helping us. So 1 kg CO2 reduction and in cost at 1.2 kg. Still there is a scope for reducing the acid. One side we are seeing the acid, yes, CO2 will react at this percentage. But what happens? We are seeing the coating in the washing plant, in the diesel washer. So again core washing, again carry out to the next stage. So it is again becoming cyclic. So still we are able to find the optimum pH for the diesel acid, but rest areas we are able to control. And the good thing is what the customer benefits. So we are doing something, but surprising from my internal customer is the paper industry, where he said, paper machine area, he said, hey Radha, there is a significant drop in OT consumption. I said, thank you sir, please let us maintain. So these are all significant intangible benefits which we got because one of these variable is steady. So we are happy that we are able to give a constant quality. So we are, as an internal customer, I am happy to, so that we have taken care. Coming to global, 1 kg of CO2 reduces 1.56 kg of carbon emission. So with now we are going for the 2070 carbon emissions, where we can, it should not be a greenwash. So where we have reduced, these data are as a industry we work on the scope 1 and scope 2 alone. But scope 3 indirectly it has helped us in reducing the CO2 reduction and caustic reductions. Wherein CO2 1.56 kg and for caustic it is equivalent is 1.35 kg of CO2. So you can calculate how you are helping in reducing the carbon emission. So we already seen other areas where we have already installed the smart sensors. So we already started in bleach plant. Our next area, what we are focusing on the millward optimization, where the digester operation, where we are swinging the chemical steam consumption. So how to match the steam and power demand with paper machine, cooking, soot blowing, we are working on that. We are yet. We hope we will come back. So to conclude, the artificial intelligence is not a substitute for human intelligence. It is a tool to amplify human creativity and ingenuity. And I hope we all will benefit with the help of AI or enhance our work with AI. I thank the management of SPB and IFTA giving an opportunity to share our experience.